Good morning. I welcome you. As the exams are coming, we have to work hard so that we can cover all the topics and we should be able to do questions which are coming in the paper. The biochemistry is left already. We are going to begin, students. What is biomolecules? First of all, I think you are aware of what I am talking about, student. We are aware of what is biomolecules. Okay, let me see the board. Biomolecules. You are already knowing what is the meaning of bio, student. Molecules of biology. What are the molecules of biology? Biology, there are molecules, students, which form the basis of our life. Inside the body, you have made up of small cells. Inside the cells, what is happening? There is a growth and production. There is a food which is being prepared. There is biomolecules which are taking part in the body. What are those biomolecules which make up your body, students? What I am saying, they are organic compounds which form the basis of life. They build up living system and responsible for their growth and maintenance. So those molecules which will build up the living system and will maintain our growth. And these organic molecules are present in the living cells. I'm talking of the living cells, student, living cells. So inside your body, you have small cells. In those cells, we are having carbohydrates, proteins, fats, and certain other molecules. So they make up our human system, human body. They are non-living molecules, organic molecules, but they are responsible for the growth, for the maintenance of our body. I hope you are a student of bio, you know more about it, that what and how this production takes place. We are saying they are present in a living cell. Present in a living cell, student. They are mostly what we will be studying in chemistry. What we will be studying in chemistry are these
Yes, sir.
carbohydrates, proteins, fats, few other lipids, and many other things which we are using in the body. They are basically essential for body functions and manufactured within the body. The body is able to manufacture them, but a large number of things we are taking from outside also, because the body cannot provide everything. They can vary in nature, type, structure, and some can be straight chain, some may be cyclic ring or both. They can vary in physical as well as water solubility and melting points. Therefore, students, from chemistry point of view, we are not biology students. We are mainly studying chemistry. From chemistry point of view, we will be studying the chemistry of these biomolecules, biological molecules which are making our system. The first one you can see we already have on the screen are carbohydrates. What are, students?
Hydrates.
Carbohydrates. Carbohydrates. We are already aware, students, that mainly the elements which make up the human body. Although in the periodic table you see now about 118 elements, you are mainly made up of carbon, hydrogen, nitrogen, oxygen. These are the four main elements, students. And beside this, there are so many other elements. I am not saying there is a phosphorus, calcium, so many iron, etc. So many things are present, but these are the main elements, four main elements which will constitute most of the human body. And they will combine in different ways to form different type of compounds, which make up our system, our body, our organs, our organs. You have actually in chemistry, what you are studying are very small molecules or reactions, And when you come to biomolecules, the size of the molecule is increasing. Biomolecules are bigger than the molecules which we are talking on chemistry. And then you have all, when you go to biology, you are talking of organs, they are the biggest. But these are the particles, these are the elements which will make us. So first, our study is on carbohydrate, student. Earlier, when they were talking about carbohydrates, usually, where the carbohydrates were present, they were primarily produced from plants, which are naturally occurring. And some of the common examples of the sugars, these are also called sugars. Glucose.
Yes, sir.
Glucose, where is the glucose? These are sugar, glucose, starch. They are well known to us. Photosynthesis. During the photosynthesis, what was happening? Plants are also manufacturing glucose, and mostly were having the general formula carbohydrates. That means they are hydrates of carbon, hydrates of carbon. That is how the name carbo. Carbo means carbohydrate. You are saying
Yes, sir.
they are carbohydrates. Mostly it was found, mostly not all, we are saying they were having general formula CXH2OY. This is a general formula.
Yes, sir.
Now, if I keep on changing the value of X and Y, I can get these type of compounds. For example, if I put X equal to 6, what I will get? C6H2. So if I put X equal to 6 and Y equal to 2, what is the story? What I am getting? C6. Or if I put this 6, what is I'm getting? C6H12O6. Okay, that is coming glucose.
Yes, sir.
But the problem is that this is not applicable for all the organic compounds, and even certain compounds which will fit into this CXH2OY formula, they are not carbohydrates. For example, acetic acid. How many carbons are there? Two carbons. X is equal to 2, and in this, students, if I how many H2O, if I put value of Y to 4 and 2, okay, 2, X to equal to 2, Y equal to 2, this also is in this formula. But acetic acid is not a carbohydrate. Acetic acid is not a carbohydrate. It is fitting into formula C2H2 twice, this compound, but it is not a carbohydrate. So earlier, what they were saying that they could be having this general formula is not correct. Similarly, there is another one, Ramnose, which is C6H12O5. Ramnose. These are some of the names which we will become familiar as we learn this topic, student. Ramnose, the formula of this is C6H12O5. This is not fitting into this formula CXH2O5, but is a carbohydrate.
Yes, sir.
So they are having some properties which we will be discussing in this topic. They are what type of properties they have, we will be talking in detail for the glucose, not for all these. So they have large number of reactions. They contain specific functional groups. And now we have changed the definition from chemistry point of view. From chemistry point of view, we are saying carbohydrates are optically active. Optically active, I'm saying. Polyhydroxyaldehydes or ketones. This is an important point. Finally, we are settling with this definition, which it says, what do you mean by optically active? What do you mean by optically active, students? Optically active. You are very well aware, any word I write in chemistry, every concept I do use in chemistry, students, the words have a meaning we must understand. You are aware what are optically active compounds? They will, you know, we have already told you compounds of carbon in which at least one asymmetric carbon is there. Asymmetric means the carbon is connected to four different groups. What happens? They rotate the plane of the polarized light. And there are two of these mirror image isomers which we told you. They were called enantiomers. One rotates the plane polarized light towards clockwise direction, and the other rotates the plane polarized light towards the anti-clockwise direction. So they are optically active. Means at least one asymmetric carbon must be there. Second, they are saying polyhydroxy. What do you mean by polyhydroxy? That they will contain OH groups. Polyhydroxy means, student, there are OH groups present in it. OH groups. Poly means more than one. OH groups are present. And third point, we are saying they are aldehyde. Either they have CHO group or they have this type of group, ketonic group. So they must possess these properties, students, chemical functional groups, in order to be qualified as carbohydrates. And you know the simplest carbohydrate and the one which you are eating, which is that which we are using, students, which carbohydrate we are using, which you are already eating. Again and again, we are taking the name of that. Which carbohydrate is that, student? Tell me the name of the carbohydrate which you are consuming in the food.
Sir, sugar.
Sugar, name the carbohydrate. Now, sugar, how do we define carbohydrate? Glucose. You know, glucose is the one which we have been talking about again. The molecular formula is C6H12O6. This will be asked in our paper, students. Glucose will be asked. What will be asked? We are going to discuss the structure and preparation and properties of the glucose. This is the most important. In this compound, there glucose is the most important. There is a fructose also, which is available in fruits, grapes, and everything. Glucose, you already know, main source from plants, and this question will be always there on glucose. We will discuss that. So already these are also carbohydrates. They they are called saccharides. Saccharides is a letter, you know, is a word which was used for them. Saccharides, mainly sugars. Sugars are called saccharides, and you know, sugars are sweet. There will be non-sweet carbohydrates also. Non-sweet carbohydrates also. We will see them. So, what we are saying, sugars, you are knowing about those. You are eating the sugar every day in your tea and other things. So, that is sucrose. What we are using is sucrose. This is a sugar, this is a carbohydrate, this is a carbohydrate, and they are sweet in taste. The sugars are sweet in taste, student. Chini, chini, though, you know about chini, this is always sweet. So, most common sugar used in a home is sucrose, and also in the milk, which is present in the milk, you know, which carbohydrate is present in the milk, students. Which carbohydrate is present in the milk, students? You know that? Which carbohydrate?
I don't know, sir.
Okay. You sugar present the lactose. Lactose, you are aware of the lactose. It is lactose. Okay. So what we are talking inside the milk also, milk has a sugar which is lactose. Lot of the food materials which you are eating, they all have sugars, carbohydrates. Therefore, students, we are now saying carbohydrates are, what are carbohydrates then? What are carbohydrates? Polyhydroxy, aldehydes or ketones,
Yes, sir.
and are optically active. Optical activity is an important property which we use in chemistry. There is an instrument, which is used for examining the optical activity, which is that you are aware of that. This question was even asked in 12th paper. Which instrument we use for measuring the substance is dextro or levo, whether it will rotate the plane polarized light towards clockwise or anti-clockwise direction. Student, you are aware of polarimeter? Polarimeter is an instrument which is used for finding out the optical activity of the compound.
Yes, sir. Okay.
Okay, keep on interacting with me, keep your energy levels high. You see that this is important, student. Exams are coming and we should be very active. We should learn, we should practice, and we should work hard. This is our point. You are a good student, you are intelligent students, but you have to work hard. That is the main thing. How much you work will that depend on how much marks you will score.
Yes, sir.
Now, how will we classify in chemistry? This is important. Every time I have talked of classification, we want to classify because what are the various types of carbohydrates, students, and this classification is mainly done on the basis of their hydrolysis behavior. Hydrolysis, I am saying. Can you tell me what is the meaning of hydrolysis, students? What is hydrolysis? What is hydrolysis, student? In chemistry, we use hydrolysis a lot. What do
Yes,
you
sir.
do in
I'm sure we did in
hydrolysis?
11th.
You are aware organic chemistry? I say hydrolysis. What you do in hydrolysis? What you add in hydrolysis? Organic compounds they do go undergo hydrolysis is a very important reaction. You are reacting
Yes,
with
sir.
water
Mm-hmm.
and hydrolysis takes place. Sometimes we are adding acids or bases when we are adding water to catalyze the hydrolysis to catalyze the
Yes,
reaction.
sir, to make it fast.
You have seen in large number of organic reactions I am doing that. So if I will react with water, what will happen? This is what we want to see. Because here you have seen the term which I am using, students, monosaccharides, disaccharides, trisaccharides, tetrasaccharides. What it means? For example, here I have written monosaccharide, student, monosaccharides. Mono means
One single.
saccharide means sugar. Monosaccharide. What do you mean by monosaccharide, students? Mono means that if I will hydrolyze it with water, it will not give simpler units or other molecules of the carbohydrates. It is not hydrolyzed. That, in other words, I can say a carbohydrate that cannot be hydrolyzed. It is a carbohydrate, but cannot be hydrolyzed. Cannot be hydrolyzed. That means if I will react with water, it cannot be hydrolyzed to give simpler units of polyhydroxyaldehydes or ketones. So it
Yes, sir.
cannot produce simpler units of polyhydroxyaldehyde or ketone. Polyhydroxy units of aldehydes or ketones. So the example of this is glucose and fructose. Glucose,
And fructose.
fructose. We are going to discuss their formulas also. We are just mentioning right now glucose, fructose, ribose. They are monosaccharides. They cannot be hydrolyzed into simpler units of polyhydroxy, aldehydes or ketone. The formula of glucose is C6H12O6. This is our glucose. The formula fructose is also C6H12O6. But it is it contains aldehyde group, it contains ketonic group. We'll be discussing the structures of both of these compounds. So for example, here we are saying, we are writing aldotetrosis, aldopentoses. What it means? What is the meaning of this? There is a general formula, general term which is used for different types of monosaccharides. What general term we are using? Let me tell you what is the general term. For example, students, some of the, I am saying there are general terms, which we use for monosaccharides. Monosaccharides. This general term is based on the number of carbon atoms. Based on number of carbon atoms. There are two types of saccharides, one which contain aldehyde group, other contains ketonic group. As I said, it can be aldehyde or ketone. What you are saying, there can be two types of monosaccharides, aldehydes or ketones. And this is the number of carbons. Number of carbon atoms. So if I put the number of carbon atoms 3, this is a triose. Triose means it is a carbohydrate. It is a monosaccharide. Triose means it is a carbohydrate, but there are 3 carbons in it. It can be aldo triose or it can be keto triose. What I say, students, that for example, what is the definition of the monosaccharides I gave you? What is the definition of carbohydrate? There should be CHO group, there should be carbonyl group, or there should be OH groups,
Yes.
and it should be active, optically active. This is the definition. Okay? These things should be present. 3. Okay? Either of these groups must
Yes,
be
sir.
present to become a carbohydrate. This is our definition. Yes or no? Tell me. Did I give this definition?
Yes, sir.
As you can see, the starting point is 3 carbons. Why the starting is 3 carbon? Why I am putting 3 carbon? Here, I have not put n equal to 1. Because students, if I have aldehyde group, then I have a C group, then I am saying there should be OH group present in this. And you are saying it should be optically active. How it will be optically active then? Tell me. So if I put something like this, student, if I put something like this, now what is happening is you can see this compound. Tell me, this compound has how many carbons? 1, 2, 3.
3, sir.
And how many OH groups are there? 2. And aldehyde group is there. And this carbon is optically active. You can see this is asymmetric carbon. Are 4 different groups attached to it? Which one? 1, 2, 3, and 4. See?
4. Yes, sir.
So if I don't have 3 carbons, then I cannot have polyhydroxyaldehyde or ketone, which will be optically active, So this is important. So how they are named keto triose. There can be aldo triose. We can have keto triose, students. And if I have students tetroses, what is a tetrose? 4 carbons. There can be aldo tetrose or there could be keto tetrose. That means there will be a carbonyl group, ketonic group here, it will be an aldehyde group, CHO group, and this is what we are saying ketonic group, which is always, there are 2 carbons on either side. So we have pentose, 5 carbon, we have hexose 6 carbon. So aldohexose. aldohexose. The glucose is nothing but aldohexose. So students, glucose is having C6H12O6. This is nothing but aldohexose. The formula of this we are going to discuss.
Yes, sir.
So we can have ketohexose, ketopentose like this. Ketohexose. This is a way to we what this is a way to just general terms for the monosaccharides which can be used. They are known as aldoses. Aldoses because aldoses means contain aldehyde group. Ketoses mean they contain ketone group student, and the number of constituting the monosaccharide is introduced. The number of carbons is the number of carbons in the monosaccharides. These are some of the examples of the monosaccharides which will be used to students. Okay, we got this idea. Therefore, monosaccharides, glucose is a monosaccharide, fructose is a monosaccharide, we are saying, ribose is a monosaccharide. They cannot be hydrolyzed simpler into more simpler monosaccharide molecules. It is not possible to hydrolyze them. So they are not undergoing hydrolysis. And you have aldotetrosis, I told you,
Yes,
aldopentosis,
sir.
aldohexosis contains glucose, galactose, ketohexosis, fructose. They are all examples of monosaccharides, and all naturally occurring monosaccharides belong to D series. Now, this is important point. What is a D series, students? This I have to explain to you. What is a D series? First of all, students, let me tell you, this is not a small d or a small l. I have used small d as dextro rotatory. Clockwise rotation when a compound is optically active. This was called plus. And I have also used levo in the optical activity. That means it is anti-clockwise rotation, which is negative in the polarimeter. This D is a capital D, student. It has nothing to do with this dextro only.
Oh, sir.
How do we say it is D? For example, what is the meaning of D, students? If I have this compound, students, if I write, supposing I have this compound. Now in this compound, student, let me put it this way. If I write something like this, students, you can see that in this compound, student, what is important, that this is a what we call as glyceraldehyde. This the name of this compound is glyceraldehyde. Glyceraldehyde, student. Important point to note is, student, this carbon, the OH group is on the right hand side. As you can see, D or L notation indicate the relative configuration. D or L indicate, students, important point to note, indicate, students, a particular relative configuration. What configuration, student, we are talking of? Relative configuration of a particular stereoisomer. Of a stereoisomer, student. Now, can you tell me, student, what is a stereoisomer? What is a stereoisomer? Important point. Anytime I write a word in chemistry, it has a meaning. Did I tell you that or not?
Yes, sir.
Anytime I write a word, it has a meaning. We should know what it is. We have told you different type of isomers, structural isomer. Now I am saying stereoisomers. What are stereoisomers? They are having different arrangement of atoms or groups in space. The arrangement is different. I can write another form of this, student. This one. Now you see the difference between the two. I have written two. Students, I have written two. One this and one this. This is one. This is my two. Do you see two? What is the difference between these two? What is the difference between these two? Tell me.
Um,
How they differ? They are stereoisomers. Why they are
um,
stereoisomers? Because they differ in the arrangement of atoms in space. Here the OH group is on the right hand side.
right
Here the
side and
OH
this my
group is
left
on the
hand
left
side.
hand side.
Yes, sir.
OH on the right. And this is the last carbon you can see. This is the next to the last carbon. This is the next to the last carbon, student. And here you can see this is called D, big capital D, and this is called L. When OH group is on the right side, the last carbon next to this student, if the OH group is on the right hand side, this is called a D. This is my D glyceraldehyde. This is called L glyceraldehyde. This is called L, student, by convention. By convention, student. This is my, I'm saying this is my D, this is my L. So what, when it will be D, when any carbohydrate will be D, student, I will see the last carbon next to the last carbon. Next to the last carbon. If the OH group is on the right, it will be D. If the OH group is on the left, it will be L. This is the way to assign the configuration of monosaccharides. The lowest asymmetric carbon atom, the lowest asymmetric carbon is compared as in this case. These are lowest asymmetric carbon. So this carbon is asymmetric because four different groups are attached: OH, CHO, H, CH2OH. Okay? Four different groups. See that? This group, they are four different groups attached to the carbon. So this carbon is asymmetric.
Yes, sir.
Okay. What I just said you, student, I said ki D and L, student, D or L. This is how we assign. These are the relative configurations which are
Yes, sir.
given to different stereoisomers. Different stereoisomers, I am saying, students, on the basis of the, this is more written in a simple form like this: OH, H, CHO, CH2OH. This is carbon. This is my carbon. Now the OH group is present on the right. This is our D glyceraldehyde. This is my D glyceraldehyde. And if I have OH on the left hand side, students, what is this called? L glyceraldehyde.
Okay, sir.
So we have two, D and L, and both are, it was found to be, we are writing two glyceraldehyde, D and L, D and L. D glyceraldehyde. Similarly, if I say glucose, the structure of glucose, we will tell you how it was obtained. But in this case of the glucose, you will find glucose has 6 carbon. It is C6H12O6, students. And this structure is written like this: 1, 2, 3, 4, carbon 1, 2, 3, 4, 5, and carbon 6. So you have OH, you have H, you have OH, H, H, OH, OH, H. So this is
Yes,
a
sir.
glucose. In this you can see The OH, this is the structure of the glucose, student. This is the structure of the glucose. This is the structure of the glucose.
Glucose.
And the last carbon is this one. Next to this is this one. So the one which is on this OH is on the right hand side. OH is on the right hand side. Then it will be D or L. It will be D or L. ठीक है? This is a
Yes, sir.
plus glucose. The plus glucose, student, the plus glucose has got OH group on the right hand side. Is it D configuration or L configuration? It is a D configuration.
Deconfiguration. Yes, sir.
D configuration. Because how many carbons are there? 1, 2, 3, 4, 5, 6. This is the carbon. This is the carbon which is present to the lowest side, which is asymmetric. Lowest asymmetric carbon. This is called lowest
Asymmetric carbon.
asymmetric carbon. Because the OH group is on the right side, this is D glucose. You have seen many times you buy glucose from the market, it is written D, it is also called D glucose. Why? Because of this configuration, students. Configuration will change, the properties will change. The activity of the glucose will change.
Okay,
Important
sir.
point to note. So here the glucose which we are talking is D glucose, student, D glucose. And this you will find is D plus D plus glucose. What it means? This is my glucose C6H12O6. D means this OH group is the lowest asymmetric carbon OH group is on the right hand side. OH group on the right hand side. Configuration is such that this OH is on the right hand side, students. And plus means optically active, it is optically active rotating towards the clockwise direction. Rotates the plane polarized light towards the clockwise
Clockwise
direction,
direction.
which is called dextro. That is small d. This is the way it rotates the plane polarized light, clockwise direction. Plane polarized light. So this was one point which we wanted to discuss, what type of configurations we can have. So what we said to you just now, that there are classification of the saccharides which we are talking, what we are telling you, that monosaccharides.
Yes, sir.
So monosaccharides cannot be hydrolyzed. Monosaccharides cannot be hydrolyzed. Then there are oligosaccharides. All the monosaccharides belong to D series. That means the lowest asymmetric carbon I am saying will have OH group on the right hand side. This is related to the stereo configuration of the molecule. So they are all D series. Next, we are saying oligosaccharides. What are oligosaccharides, students? Oligosaccharides contain, students, they will give generally 2 to 9 monosaccharides on hydrolysis. That means they contain more than one monosaccharide molecules in them. You know there are so many such compounds which on hydrolysis will give more than one monosaccharide. And we are going to take example. I am saying on hydrolysis they give 2 to 9 monosaccharide, and they can be same or different. For example, sucrose, maltose, lactose, and there are trisaccharides. Sucrose is a disaccharide. What it means? That on hydrolysis it will produce two molecules of monosaccharides, disaccharide. What I am saying, students, sucrose is a disaccharide. What is the meaning of a disaccharide, student? That if I will hydrolyze this,
Hmm.
then it will produce, di means two monosaccharides.
Okay, sir.
It is actually condensation product of two monosaccharides. And here we have some the sucrose. Sucrose is the sugar which we are eating. White sugar which you have at home is sucrose. If I will react with water, what will happen? It will give one molecule of glucose and one molecule of fructose. So sucrose will produce glucose and fructose. They are the same formula, but the two are different because glucose is a aldohexose, it is a ketohexose. We just told you what are aldohexoses and ketohexose. Glucose is aldohexose and this is ketohexose. These are difference between the two. Sucrose, maltose, lactose, they are disaccharides. On hydrolysis, they will produce two units of monosaccharides. They can be same or they can be different. Trisaccharides will be those which will produce three monosaccharides on hydrolysis. Tri means on hydrolysis they will give how many? Three units of
Yes, sir.
tri. Three units of monosaccharides will be obtained if I have trisaccharides. So further polysaccharides. What are polysaccharides, students? They contain large number of monosaccharide units. So on hydrolysis, students, they will produce large number of monosaccharides, more than more than 10, more than 10 monosaccharides. And some of the examples already you are aware of starch. They say that don't eat too much starchy food. People who are eating too much starchy food because starch, is a polysaccharide and they may contain more than 100 glucose molecules in them or more than 100 monosaccharide units.
Yes, sir.
And on hydrolysis inside your body, they will produce large amount of glucose molecules and so much of sugar will be there in your body. So much of monosaccharides will be there in your body, which are not good for health. But starch is one example, cellulose, glycogen, gums, these are all polysaccharides. They will yield, what we are saying, they will yield large number of, they will produce, students, large number of monosaccharides on hydrolysis.
Yes, sir.
On hydrolysis. So starch is the common example which we have given for you. So starch, cellulose, the general formula is C6H10O5 and N can be, you can see 100 to 3000 units. There can be 100 to 3000 units of monosaccharides. They will give large amount of glucose inside your body. And lot of
Mhm.
people, love to eat sugar, and
Yes, sir.
how much sugar will go inside our body. The system will become just, it will damage our system because people are eating too much sugar, student, too much sugar. It's not good because so much of glucose is entering into the body. And diabetes and so many other ailments people are suffering for because of this. So we are today's talking of sugar-free diet, student, because sugar is present in every fruit also. All the material which we are eating, they have some amount of carbohydrates. So why do we need artificial extra sugar which you are eating? White sugar is a poison for the body. Okay. Now we are saying sugars, carbohydrates we are saying are either in the sugar category or non-sugar category. What is the difference? They are usually crystalline solids, soluble in water and sweet in taste.
Yes.
They have a taste, student, which is sweet. And once it is developed, people will love it. Sweet. Meetha, meetha khana hai. ये जो मीठा खाने का अब तो कम हो गया, बहुत कम हो गया, बच्चे अब नहीं खा रहे मीठा। आई सीन सम पीपल मिठाई बहुत ज़्यादा खा रहे हैं, मीठा, वो स्वीट है, उसमें क्या है, शुगर, शुगर नथिंग, ऑल एरिएटेड ड्रिंक्स क्या है, शुगर, they contain lot of sugar, students, then all this carbohydrate is going inside your body. तो ये सब शुगर जा रहा है, ग्लूकोज जा रहा है. These are called sugars if they are sweet, student. They are crystalline solids soluble in water, crystalline soluble in water, and sweet in taste, soluble in water, sweet in taste. And what are the non-sugar, student? They are amorphous solids,
Hmm.
insoluble in water,
Yes, sir.
insoluble in water, and tasteless. They are called non-sugars. Non-sugars. Further important question which has been asked in the paper is on reducing and non-reducing sugar or carbohydrates. This is an important question for the paper. They will ask you what is the difference between reducing and non-reducing sugars. You already have some idea, student. What is the meaning of reducing sugar, student? What is the meaning of reducing?
So does it remove oxygen?
No. You have seen there are certain tests in the organic chemistry which are given by the compounds which contain CHO group or C double bond O group.
Yes, sir. Hmm.
So reducing sugars are those which reduce these reagents. Which test we are talking about mainly? Which test we are talking? These are tolerance reagent test, student. There are two important tests, tolerance reagent test and second failing solution test. Whenever there is a free CHO group, whenever there will be free student CHO groups, what will
Sir, your
happen?
voice is
They will
breaking.
give this
Please
test.
repeat.
If there is a free CHO group, they will produce tolerance reagent test, silver mirror test, and failing solution test. You have seen red Cu2O red colored precipitate is formed. So the reducing sugars give this type of test. The condition is there should be free functional group, student. They should have free CHO or C double bond O group present. Unless that group is present, this test will not be given. Therefore, there are two types of sugars, reducing and non-reducing sugar. Non-reducing sugars, students, are those which do
Your voice
not
is
reduce
breaking.
these reagents, which do not reduce which reagents, tolerance reagent and failing solution. They are non-reducing sugars. We will find monosaccharides are all, whether aldoses or ketoses, are all reducing sugars. Monosaccharides are examples of reducing sugar, student. Monosaccharides, I am saying, they are examples of reducing sugar, student. Point to be noted for exam. So glucose is a monosaccharide, fructose is a monosaccharide, mannose. So these compounds, students, will be reducing sugars, reducing sugar. They will give tolerance reagent test and also the test which we are talking of, Fehling solution test, these are called reducing sugars because their functional group CHO is available. They are free CO or CHO group, then they will give these type of test students. Those ketones, they also undergo produce CHO group because they have a lot of OH groups present in them. And once they do that, they will give these type of tests which we are saying they will be reducing sugars. So their tolerance reagent, Fehling solution, they oxidize aldehydes to carboxylate ions. So you will get that test or color. Now, students, the question is, how can you prepare glucose? How can you prepare glucose? The formula of glucose is C6H12O6, students, and this we said is a monosaccharide. Therefore, we can produce it by hydrolysis, student. Hydrolysis of disaccharide, for example, sucrose. Sucrose is a disaccharide. So when it is hydrolyzed, as I have written, this is my sucrose, students. The sucrose is hydrolyzed. It is usually boiled with dilute HCl. Boil sucrose with dilute HCl, student. What will happen? Sucrose will produce glucose and fructose. Both have the same formula, but this is the aldohexose, this is a ketohexose. It contains ketone group, it contains aldehyde group. And they are obtained in equal amounts acid hydrolysis of the sucrose. Further, student, we can obtain from the hydrolysis of sucrose. Second important point is the starch, students. As we said, starch has more than 100 molecules of glucose. So we can do hydrolysis of starch. Hydrolysis of starch, student. So we have to boil. What we have to do, student? Boil this starch. Boil by adding. What we will do, student? We will add dilute sulfuric acid and boil. Dilute sulfuric acid. And you will boil at 3.
I'm sorry, your voice is breaking a lot.
Achha, I'm connecting again.
Okay, yes, sir.
Now the sound is coming. Can you listen me? Hello? The sound is coming. Can you listen to me? Kinal, sound is coming.
Yes, sir. Sir, it's breaking though.
Okay. Now we are talking about the preparation of the glucose. The one of the method of preparation of glucose is the hydrolysis of sucrose. Sucrose is that sugar which you are eating at home. Sucrose is a disaccharide. On hydrolysis, it will produce two units, one of glucose and one of fructose. On same times when glucose and fructose will undergo condensation, they will be forming sucrose. We will see this important point. So the sucrose has two monosaccharides in it. We will show you the structure of sucrose also in the next class. So this will produce glucose and fructose. And as I said, starch contains large number of glucose molecules, 100, and how many we said 100 to 3000. Or so what
Yes, sir.
happens when you boil the starch? What will happen? Starch is boiled with dilute sulfuric acid at 393 Kelvin to 3 atmospheric pressure, then you will be able to produce glucose. Therefore, these are some of the methods of producing glucose. And you know that we are eating a lot of carbohydrates in our body, students, and a lot of extra glucose is stored inside our body in the form of in the liver in glycogen. Liver in glycogen, where we are storing, the liver has got, the students, extra glucose in the form of glycogen. So there we have told you what we told you in this lecture, biomolecules. Those molecules of which are actually organic molecules, carbohydrates, fat, proteins, of which our body is built, student, made. And we are studying the chemistry of these, how they are prepared, what are their properties, we will study, and the structures of these molecules.
Yes, sir.
This in chemistry, this is important because in this chapter we can score full marks. Full marks, certain chapters are easy, we can score full marks. We have just to understand them and learn them, that's all. Nothing is there for us. Glucose will be asked in the paper, very important. We will be discussing in the next class the structure of glucose, which is a very vital question for the paper. ठीक है, we will continue your classes. We will like to finish the biochemistry part. Then we want to revise the physical part. We will be doing questions, important questions
Yes, sir.
from every chapter. Important question from every chapter will be solved. So we will see you tomorrow at 11 a.m. in the morning.
Okay, thank you, sir.
Okay. एक बार थोड़ा